Crisis Management and Systemic Failures. Lessons from the Charkhi Dadri Catastrophe. The 1996 mid-air collision in India, resulting in the loss of 349 lives, remains one of the most critical case studies in aviation and operational risk management history. The accident between Saudia Flight 763 and Kazakhstan Airlines Flight 1907 was not an isolated event, but the outcome of a succession of failures and safety barriers that are now fundamental in managing complex projects and critical infrastructure. From the perspective of resource management and safety engineering, the disaster reveals systemic vulnerabilities that turned a communication error into an unprecedented tragedy. Language barriers and CRM, crew resource management, failure. The investigation found that the insufficient English proficiency of the Kazakh crew was a determining factor. In international project management, clear communication and the use of standardized phraseology are safety assets. The ambiguous interpretation of altitude instructions demonstrated that without a robust communication protocol, the risk of human error grows exponentially in high-workload environments. Technological limitations and lack of redundancy. At the time, New Delhi's airport lacked secondary surveillance radars that could provide controllers with precise aircraft altitude data. Furthermore, collision avoidance systems, TCAS, were not mandatory. For capital project managers, this scenario reinforces the importance of redundancy. When human control fails, the technological system must act as an independent last line of defense. The accident accelerated the global mandate for TCAS-2, shifting the safety paradigm to a model where technology monitors and corrects deviations in real time. Operational culture and flight discipline. The unauthorized descent of the Kazakhstan Airlines aircraft into the Boeing 747's flight level highlighted failures in operational discipline. In highly complex projects, strict adherence to established processes and cockpit coordination are what separates success from catastrophe. The Charkhi Dadri tragedy served as a catalyst for the International Civil Aviation Organization, ICAO, to implement far stricter language proficiency standards in safety audits. This historical event teaches us that safety is not a static state, but a continuous process of risk mitigation and learning from failures. The evolution of post-1996 aviation standards reflects the transition to a data-driven management approach and the absolute standardization of global processes. From your perspective as a project professional, do you believe organizations invest enough in redundancy technologies, or do they still rely excessively on human performance under stress? How do you assess the importance of language standardization in global engineering projects? The introduction of TCAS-2, Traffic Alert and Collision Avoidance System, represents one of the most significant safety advancements in modern aviation. Following the Charkhi Dadri disaster and other incidents, its mandate was accelerated globally. Key statistical impacts. 1. Dramatic reduction in mid-air collisions. Since its widespread implementation in the late 1990s and early 2000s, mandatory for all aircraft with more than 30 seats or a maximum takeoff weight over 15,000 kilograms in most controlled airspace, there has not been a single mid-air collision between TCAS-2 equipped commercial aircraft in controlled airspace where the system was fully operational and procedures were followed. The most serious incidents since then have involved non-equipped general aviation aircraft or scenarios where TCAS was inoperative. 2. High rate of effective RA issuance. Studies by agencies like the FAA and Eurocontrol show that TCAS-2 issues hundreds of RAs, mandatory climb-descend commands, annually worldwide, successfully resolving potential conflicts. Data indicates it prevents several critical near misses each year. 3. Shift in accident causation. The focus of collision risk has shifted from see and avoid failures in controlled airspace to risks during approach and landing, runway incursions, or in uncontrolled airspace with non-cooperative traffic.
TCAS is highly effective against other transponder-equipped aircraft, but cannot detect aircraft without an operating transponder. 4. Enhanced safety culture. TCAS-2 has fundamentally changed cockpit and ATC culture. It serves as an independent, redundant safety layer that monitors the entire airspace system. Its commands are now considered paramount. Pilots are trained to follow RAs immediately, even if they contradict ATC instructions. This has formalized a last-ditch technological barrier. A specific case study, the Uberlingen mid-air collision, 2002. This tragedy ironically underscores TCAS-2's importance in the catastrophic consequences of procedural failure. Two aircraft, both equipped with TCAS-2, received correct opposite RAs, one to climb, one to descend. However, one crew, following conflicting instructions from an overworked air traffic controller, disobeyed the TCAS RA and climbed into the path of the other aircraft, which was following its own TCAS descend command. This highlighted that technology alone is insufficient. Strict procedural adherence is essential. This accident led to even more robust training, emphasizing that follow the RA is an absolute rule. Conclusion for project management. The TCAS-2 story is a powerful lesson in systemic risk mitigation. It demonstrates that redundancy is non-negotiable. It acts as a final, independent check on human and systemic errors. Standardization saves lives. A global, mandatory standard created a universal safety net. Technology and procedure are inseparable. The only most advanced system fails if protocols are not followed. Regulation drives safety. Proactive mandates based on past failures can transform an industry's risk profile. For project managers in critical infrastructure, the analogy is clear. Investing in automated monitoring systems, fail-safes, and rigorous drill-based training on emergency protocols is not an expense. It's the ultimate insurance against low-probability, high-impact catastrophic failures. If you enjoyed the video, please leave a like, subscribe to the channel, and share it with your friends.